Namaste, welcome to Knowledge Plaza YouTube channel. It is all about mathematics. So today, as I'm before you to discuss about irrational numbers. How can we say the numbers are irrational? As we know that decimal expansions of the numbers in the previous classes. Okay, if the numbers have a finite number of digits, then we say that terminating decimal expansion and they are rational numbers. And the numbers which do not have finite digits after the decimal point, but the digits are repeated, then we say that the numbers are, or the decimal expansion is non-terminating recurring decimal expansions. So non-terminating recurring decimal expansions are converted into p by q form. Then they are also the real numbers. Sorry, they are also the rational numbers. Then what about non-terminating, non-recurring decimal expansions? Let me have the example. 0.1010010001 and so on. 1.1432 and so on. 2.20, 200, 2000, so on. So these are the real numbers, but their decimal expansion is not end and the digits are also not repeats. Okay, so these kind of numbers or decimal expansions are known as non-terminating, non-recurring decimal expansions. So these are the non-terminating, non-recurring decimal expansions, and these numbers are known as irrational numbers. These numbers are known as irrational numbers. So remember the point that irrational numbers have no end for the digits after the decimal point, or the non-terminating, non-recurring decimal expansions are known as the irrational numbers. Irrational numbers always have the non-terminating, non-recurring decimal expansions. Okay, let me discuss about the exercise 1.3 from the textbook NCERT Mathematics. So let me discuss about the exercise 1.3. In the first main, write the following in the decimal form and say what kind of decimal expansions do they have. Okay, let me have first example. 36 by 100. The decimal expansion or decimal form of this number is 0.36. We have to place the point after two digits because we have 100 there, so two zeros there. Count the numbers from the right, 1, 2 and then point, 0.36. The decimal expansion is terminating decimal expansion. Let me have one more example. 1 by 11. We'll have the decimal expansion as like this, 0.090909, and it is continuous. It can be written as 0.091 because these two digits are repeated, so that's why we can write it as a 0.09 bar. Okay, so it is a kind of, what kind of decimal expansion it is? It is non-terminating, because there is no end for the digits. Non-terminating, recurring, because the digits are repeated, so that's why it is non-terminating recurring decimal expansion. Okay, let me have one more example. 329 by 400. The decimal expansion will be 0.8225. 0.8225. So it is also the terminating. Why it is terminating? The division process ends and the point after the finite digits are there. So that's why it is terminating decimal expansion. Okay, let me have second main. Okay, the second main is, you know that 1 by 7 can be written as 0.142857 bar. Okay, so 142857 are the repeating blocks, so that's why 0.142857 1 by 7 is expressed, and it is the non-terminating recurring decimal expansion. Now, can you express 2 by 7, 3 by 7, 6 by 7, 5 by 7 as like this only, without actually performing the division process? Without actually performing the division process, I have to express 2 by 7, 3 by 7, 4 by 7, 5 by 7 and 6 by 7 in the form of as like that of 1 by 7 is expressed. Okay, let me see how can we express 2 by 7, 3 by 7 and so on. Okay, so 1 by 7 can be expressed as 0.142857 bar. 142857 bar. So now we have to express 2 by 7 as like this only, and 3 by 7 as like this, and so on. So let me express them. 2 by 7. 2 by 7 can be written as 2 into 1 by 7. 2 into 1 by 7 is 0.142857. Okay. Now multiply 2 into 0.142857. What will we be getting? We will getting 0.285714. It is also the repeating block. Okay, we may check it by doing the division process after expressing this all. Next, 3 by 7. 3 by 7 can be written as 3 into 1 by 7. So it is 3 into 0.142857 bar. So multiply that 3 into 0.142857. What will we have? We will have 0.428571. 0.428571. Okay, in this way we are going to express, or we are going to represent the given decimal expansion as like that of the 1 by 7. So we may continue for 4 by 7, 5 by 7 and 6 by 7 in this way. Okay. Okay. Let me have third example. Okay. Third example is express 0.47 bar. Only for bar is for the 7. That means it represents 7 is the repeating digit in the given decimal expansion in the form of P by Q. So let me write 0.47 bar as X. Let X is equal to 0.4777. Call that as equation 1. Okay, depending on the problem you can write the sevens. Okay, now which is the repeating block here? 7. Only the 7 only is the repeating block. So multiply equation 1 by 10. Multiply equation 1 by 10. Then 10x is equal to 4.777. So this is equation 2. This will be shifted to the 4.77 as it is. Okay, call it as equation 2. Now subtract equation 1 and 2. Subtract equation 1 and 2. 10x minus x is equal to 4.777 minus 0.477. Okay, next 9x is equal to what we have. Subtract this one. 4.777 0.477 7 minus 4 is 4.3. Okay, then x is equal to 4.3 by 9 r. So in the numerator decimal there, so to convert that decimal into whole fraction we are getting 43 by 100. So here 43 by 90, that a 10 is multiplied to the 9, so we are getting 43 by 90 is the value of x. In this way we can convert the given non-terminating recurring decimal expansions into P by Q form as we studied in the previous class only. Okay, let me have one more example about this only. If you have any doubts, you may comment in the comment box. Express 0.001 bar. Express 0.001 bar in the form of P by Q. So how can we represent the same way which we have done? So let we have x is equal to 0.001 repeating block. So this is equation 1. Now how many digits are repeated here? 3 digits are repeated. So multiply equation 1 by 1000. Why have to multiply the 1000? The 3 digits are repeated, so that's why we have to multiply it by 1000. If 1 digit is repeated, 10. If 2 are repeated, 100. If 3 are repeated, then 1000 we have to multiply. Okay. Then equation 1 becomes 1000. X is equal to 1 point. The point is shifted to here. So these zeros are neglected. So 1.001. Okay. Call this as equation 2. Now subtract equation 1 and 2. What will you have in 1000x minus x is equal to 1.001 minus 0.001. It is enough. depending on the subtract. Okay, 1000x minus x is 999x, which is equal to 1.001 minus 0.001 means it is 1. Then x is equal to 1 by 999. So 0.001 bar can be expressed as 1 by 999. Okay. Let me add one more. Next main. So next example is surprising for you, that is express 0.9999 so on in the form of P by Q. You are getting surprised by this. If we convert the 0.999 in the form of P by Q, you will get wonder. Let me see what wonder you will getting. 0.9999. It continues. So let me take it as x. Call this as equation 1. Next, which digit is repeated here? Only one, that is 9 only. So we have to multiply it by 9. Multiply equation 1 by 10. Multiply equation 1 by 10. What we having? 10x is equal to 9.99 and so on. Okay, also equation 2. Subtract 1 and 2. What we are getting? It is 10x minus x is equal to 9.9999 minus 0.9999. 10x minus x is 9x, this is equal to, it is also 9, and x is equal to 9 by 9. 9 by 9 means it is 1. So wonder is 0.9999 infinity is approximately equal to or infinitely equal to 1. Okay, 0.999 is nearly equal to or infinitely equal to 1. So this is a surprise you will getting your hard KPA. Okay, let me discuss one more example. Okay, let me have next exercise question. What can the maximum number of digits be in the repeating block of digits in the decimal expansion of 1 by 17? So in the decimal expansion of 1 by 17, what would be the maximum digits? Let me find it by the division process. Okay. So here you will getting nearly 16 digits. You can perform that division process. You are getting nearly 16 digits. Okay, division process, that is 17 is divides the 1. That means 17 is not cannot divide the 1, or 1 cannot be divisible by 17. So it is 0 point. Then it becomes 10. Then also it is not divisible. So it has 2 plus 1 more 0. Now it becomes 100. So next continue the process, that is 17 5s are, that is 85. How much left? So 15, and then 150 becomes, so it continues. You will getting the repeating blocks as 588 235 29 411 6 4, 7. This is the repeating block. When you did the division process to get the decimal expansion of the 1 by 17. So how many digits are there in the repeating block? Is 16 digits are there in the repeating block. Okay. Actually, you have to perform the complete division process. After that, you will getting the repeating block of this decimal expansion. Okay. So there are 16 digits are there in the decimal expansion of 1 by 17. Okay, let me discuss about the next question. Look at several examples of rational numbers in the form of P by Q, where P and Q are integers with no common factors other than 1 and having terminating decimal expansions. Can you guess what property Q must satisfy? So, rational numbers are of the form P by Q. P and Q have only the factor that is 1. So, P and QR must have the factor only 1. Okay, let me see some examples. Depending on those examples, I have to say the what property that Q must satisfy. Let me see what the property does the Q satisfy. Let me have an example. Two by 5. What is the decimal expansion of 2 by 5 here? 2 by 5 is 0.4, right? Next, 3 by 2. 3 by 2 is 0.15, right? And next, 7 by 8. What would be the decimal expansion? It is 0.875. And next, 7 by 10. It is 0.7. Observe the Q here. Observe Q. What is the value of Q here? 5. Here 2 and 8 and next 10. Here P and Q does not have any common factors other than 1. 2 and 5 have no common factors other than 1. 1 is the common factor for these two, and 3, 2. They are also having the common factor 1. 7, 8. They are also having the common factor 1. 7 and 10. They are also having the common factor 1. So decimal expansion of these numbers is a finite decimal expansion. Okay, and then here 5, 2. Okay, if all the denominators are either 2 or powers of 2. All the denominators are 2 or powers of 2. Look at here. Here is 2 and it is the power of 2. Okay. Here is 5 and this is the power, and its power is 10. Or it is the combination of both 2 and 5. Okay. All the denominators of the decimal expansions, when they have no common factors other than 1, they have the denominators as 2, 5 or their powers, or the combination of 2 and 5. Okay, here the combination of 2 and 5. 10 can be written as 2 into 5. Here it is the power of 2 and 2 and 5. Okay, 2 and 5 are the common denominators and their powers, or combination of both 2 and 5. Okay, this is the property that a Q satisfy. Q satisfy here all the denominators are 2 and 5 or 2 or 5 or their powers, or the combination of both 2 and 5. Okay, this is the property that Q satisfies. Next example, write 3 decimal expansions or non-terminating, non-recurring. Next main is write the 3 decimal expansions which are non-terminating, non-recurring. So non-terminating, non-recurring decimal expansions means they are the irrational numbers. You can write root 2, root 3, root 4, root 5 and so on. These are the irrational numbers which are having the non-terminating, non-recurring decimal expansion. But here they are asked write the decimal expansions. Those decimal expansions is non-terminating, non-recurring. Let me write 0.101001000, so 2.2010, sorry, 2002000 and so on. Okay, 3.142857 and so on. These are the examples for the decimal expansions. Those decimal expansions are non-terminating, non-recurring. Okay, you can give any other examples for this kind. Okay, if they are asked, write any 3 decimal expansions which are having a non-terminating, non-recurring decimal expansions, you may write like this. Okay. Next, find 3 different irrational numbers between the rational numbers 5 by 7 and 9 by 11. Okay. Find 3 different irrational numbers between the rational numbers 5 by 7 and 9 by 11. To find the irrational numbers between 5 by 7 and 9 by 11 or between any rational numbers, you have to find their decimal expansion firstly. Okay, 5 by 7 and 9 by 11. As you know that in between any 2 rational numbers there exist infinitely many rational numbers. So here also there exist infinitely many irrational numbers also. Okay, let me write some examples, or let me write decimal expansions of the irrational numbers in between 5 by 7 and 9 by 11. So decimal expansion of 5 by 7 is 0.7142857. Repeating block. Okay, and 9 by 11 is 0.81 block. So decimal expansion of 5 by 7 and 9 by 11 is 0.714285 or and 0.81 bar. Okay, so in between these two, the irrational numbers exist. There are infinitely many irrational numbers are existed. So among them, we can write any 3 irrational numbers. It is just writing the random numbers which are greater than 0.714285 and less than 0.81. In between these two, we can write any numbers. Okay, they have no end for the decimal digits. Okay, let me write. The next digit must be 0.728571 and anything 0.73461321 and so on. And next 0.74567129 or anything. Okay, these are the irrational numbers existed between 5 by 7 and 9 by 11. These are not only, you may write any numbers. Okay, though Since they have no n for the digits, so you can write any numbers. They will become the irrational numbers between any two rational numbers. However, remember the question that if they are going to ask the find any or find 3 or any number of irrational numbers between any two rational numbers, you just have to find firstly the decimal expansion of the given rational numbers, and then you have to write the irrational numbers like this way. Okay. Have any doubts? Please comment on the comment box. So this is all about the exercise 1.3, and few more left. You may solve at your home. Okay. Thank you.